I'm Chaitanya, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, located at Dundigal, Hyderabad. Good morning to one and all. Today we are again going to have one more discussion on the fundamentals of probability. In the last lecture, we have defined the probability, the concept of probability mathematically, and we have seen the additive law of probability, and also we have seen some problems related to the additive law of probability and classical definition of probability. Now we are going to continue our discussion on the fundamentals of probability. So let us start our discussion without a delay. So our lecture is the probability to the lecture on probability. That is the second lecture on probability. Now these are the things we have discussed in the last lecture, that is random experiment, an experiment whose result cannot be predicted in advance with a 100% accuracy. Namely tossing of coin, rolling a die, picking a card from a deck of cards. All these are examples of random experiments. Sample space. The sample space is nothing but the set of all possible outcomes related to the random experiment capital. If you toss two coins at a time, you will get the possibilities head tail, head head, tail tail, and tail head. So in that way you can list out all the possibilities of the sample space associated with any random experiment. So random experiment nothing but competitive situations, the games, the sports, or the exam, or the business situations, or the political elections, everything comes under random experiments. Now the set of all possibilities related to the random experiment are known as the sample spaces. And then we also know what do we mean by an event. An event is nothing but any subset of capitals is called as an event. So we also discussed mutually exclusive. That means if A happens, B never happens, and B happens, it will not allow to A to happen. That is, A and B cannot happen simultaneously. That is called mutually exclusive. Same way, equally likely events we have defined. And also we have seen the axioms: axiom of positivity, axiom of certainty, axiom of union. Also we have seen the additive law of probability. P of A and B is equal to P of A plus P of B minus P of A intersection B. And in analogs to that, we also seen the probability of A union B and C formula, that is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. Now we are going to continue some more examples related to the probability. We are considering the first example. The example says that finding the probability of selecting a black card or a 6 from a deck of 15 cards. Before going to solve this problem, let us discuss the structure or composition of a deck of cards. In probability, by a deck of cards, we mean a set of 52 cards. That means, in general, we may use joker cards, etc., etc., extra cards while playing cards. But in probability, we ignore all extra cards like jokers, etc., etc. We only consider purely the numeric cards, that is 52 cards only. So from here onwards, the word deck of cards means a 52 card set only. If you see the structure of 52 cards, basing on the backside color, the cards are divided into two kinds, namely the black colored cards and the red colored cards. If you see the backside color of the cards, half of them are black colored and half of them are red colored. So basing on the backside color, there are two different sets of in the 52 cards. 26 are red and 26 are black. Now if you come to the front side of the cards, there will be a symbol printed on the leftmost corner, and depending on the symbols, the 52 cards are divided into four categories, namely spades, that is the symbol of spade, and hearts, the symbol of heart, and diamonds, the symbol of diamond, and clubs, the symbol of club. There are four categories based on the symbol printed on the front side of the card, that is spades, diamonds, clubs, and hearts. Each group consists of 13 cards. So 4 13s are 52. And numerically, each card is nothing but the numbers 1, 2, 3, so on, 10, 11, 12, 13. So 13 cards represents numerically the numbers 1 to 13, that is 1, 2, 3, 4, so on, 10, 11, 12, 13. But for the sake of interest in the game, number 1 is not at all called as card 1. It is known with a special name called ace. So ace is the special name of card numbered with 1. And card numbered with 11 is known as jack. And card numbered with 12 is known as queen. And card numbered with 13 is known as king. That means the first card is called as ace, and the 11th card is called as jack, and 12th card is called as queen, and the 13th card is called as king. So automatically there will be 4 kings and 4 queens, 4 aces and 4 jacks. Namely, the spade king, heart king, club king, diamond king. In the same way, spade queen, heart queen, diamond king, like that we can divide. There are 4 kings, 4 aces, 4 queens and 4 jacks. So red cards consist of 2 kings, 2 queens and 2 jacks, 2 aces. Similarly, black cards consist of 2 kings, 2 queens, 2 jacks and 2 aces. Also, the cards jack, queen and king, the 3 cards together are known as face cards because they contain human faces. They have human faces, so they are called as face cards. So in total, a deck of cards consists of 12 face cards. 4 threes are 12. 3 from spades, 3 from diamonds, 3 from hearts, 3 from clubs. 4 threes are 12. So red faces will be 6 and black faces will be 6. So this is the composition of 52 cards. Now we are given with the problem that if we select a card at random, what is the probability that the selected card will be either a black card, that is black color on the back side, or it will be a 6 from a deck of 52 cards. So let us look into the solution. First, we represent black with the event B and we represent getting 6 with 6. So we simply name black card with B and getting number 6 with 6. Then if we translate getting either black card or 6 into mathematics, we'll get that P of B union 6 because OR can be translated as union. We got the event probability of B union 6. Now by using the additive law, P of B union 6 is nothing but P of B plus P of 6 minus P of B in section 6. So as per the additive law for 2 events, it is nothing but P of B union 6 is nothing but P of B plus P of 6 minus P of B in section 6. Let us see one by one. P of B means getting a black card. So how many black cards are there? There are 26 black cards. So the number of favorable cases of black cards are 26 and total number of deck cards are 52. So probability of getting a black card is nothing but 26 over 52. That is 50% of chance to get a black card. Now let's come to the second event, P of 6. That is the probability of getting the number 6. How many cards with number 6 are there? There are total 4 cards with number 6 on their front side. So 6 numbered cards are total 4. So the probability of getting 6 is 4 by 52 and hence it is 1 by 30. Now what is the meaning of getting a probability B in section 6? That is, if we interpret it in the literal words, it means that getting a black card with number 6, that is a black card with 6 number. So how many black cards with number 6 on their front side? There are 2 cards with 6 on their front side and back side color black. So the probability of getting a black colored 6 number is 2 by 52, and by substituting these values we get the answer p of b in 6 p of b plus p of 6 minus p of b in section 6 as 26 by 52 plus 4 by 52 minus 2 by 52, which is nothing but 28 by 52. So in this way we can have an example of solving or finding probability of two events by using the additive law of two events. Now let us have a look into another problem. Here the question says that what is the probability of getting a 7 when two dice are thrown at a time. Before that, I want to tell you one important thing. That is, if you toss a coin, the possibilities are only head and tail. That is two possibilities. If you toss two coins at a time, the possibilities are head head, head tail, tail head, and tail tail. That is four possibilities. That is two square. If you toss three coins at a time, the possibilities will be two cube. So in general, if you toss n coins at a time, the possibilities will be 2 power n. So number of possibilities related to a coin tossed n times are 2 power n. Same way, if you roll a die, the possibilities are 6 because the faces are 1, 2, 3, 4, 5, 6. The possibilities of rolling a die for one time is 6. If you roll a die for two times, then the possibilities will be 6 times 6, that is 36 possibilities. That is 6 square. The same way, if you roll 3 dice at a time, the number of possibilities will be 6 cube. In general, if you roll a die for n times, the possibilities will be 6 power n. So, with this knowledge, in this problem, as we have rolled 2 dice at a time, we have thrown 2 dice at a time, the possibilities are 6 square, that is 6 6 are 36 possibilities. If you list them, the probabilities will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3 3, 3 4, 3 5, 6 6, so on, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So there are 36 pairs we can list out. Now that says that the total number of outcomes are 36. So n of s is 36. But the interest in which we are interested is the event in which we are interested in this game is getting a sum 7. That means if you roll 2 dice, we'll get two numbers. One number on one die and another number on second die. If we add two numbers, what would be the sum? And our interest is the sum should be 7. That is, if you add this number and this number, the left side number and the right side number, the sum should be 7. What is the probability? So let us consider all the possibilities which favors getting sum 7. If you check keenly, we will see that the favorable pairs are 3 4, 4 3, 2 5, 5 2, 1 6 and 6 1. I'll repeat: 2 5, 5 2, 3 4, 4 3, 6 1 and 1 6. So there are total 6 favorable outcomes, and hence the probability of getting sum 7 is 6 over 36, that is 1/6, that is 16.666% of chance getting sum 7. In the same way, you can check sum 9 or sum 11 or sum 5, etc., etc., in the same logic. Now, we are going to see one more example which states that finding the probability of getting 2 heads when 5 coins are tossed. So, 5 coins are tossed at a time. As I said just now, when a coin is tossed, the possibilities will be 2 power 1, 2 coins, possibilities will be 2 square, 3 coins, the possibilities will be 3, 2 cubes, so on. But in this problem, we have tossed 5 coins. So the possibilities are 2 power 5. That means the total number of possible outcomes are 32. 2 power 5, that means 32 possible outcomes. And our interest is among 5 coins, we have to get 2 heads. So what are the favorable outcomes? So we want to get exactly 2 heads. So the favorable outcomes will be, out of 5 coins, we are expecting 2 heads. So out of 5, we have to make two combinations. So 5C2. 5C2 will be the correct value. So 5C2 means 10. So favorable outcomes of getting two heads is out of 5 coins is 5C2 and hence it is 10. So probability of getting two heads is nothing but favorable outcomes by total number of outcomes according to the classical definition. So favorable outcomes are 10 and the total number of outcomes are 32. So 10 by 32 is the answer and hence 5 by 16 is the probability that we require. Now here we are going to see one more problem which states that a box contains two red balls, three blue balls, and four black balls. I'm repeating, the box contains two red balls, three blue balls, and four black. That means the box contains in total 2 plus 3 plus 4, that is 9 balls. So the box contains 9 balls, out of which 3 balls are drawn at random from the box. So the box contains 9 balls and we have picked only 3 balls from the box at random. Now we are asked to find that the probability that the drawn 3 balls are different colors and the selected 3 balls are of same color, and the third question is the first two balls are same color and the third ball is different color. So we have to find three probabilities, that is getting all selected 3 balls are different colors, selected 3 balls are of same color, and 2 are of same and third one is different. Let us see how we are going to solve this problem. So number of red balls 2, number of blue balls 3, and number of black balls 4. So total there are 2 plus 3 plus 4, that is 9 number of balls. So the total number of balls is 9 and number of balls we have chosen at random is 3. So the total number of cases, the total number of possible cases or total number of possible selections out of 9 balls selected 3 balls is 9C3. So 9C3 is the N of S, that is out of 9 balls we have selected 3 balls. So total number of possible outcomes is N of S is 9C3. Now let us take the first bit. The first bit says that we have to find the probability of getting 3 balls of different colors. So all the 3 selected balls should be of different color. So we know the rule of counting or rule of multiplication. If you are performing 3 different tasks, the first task can be performed in M ways and the second task can be performed in N ways and the third task can be performed in P ways, then the 3 tasks can be performed in total in M into N into P ways, that is called rule of multiplication. So if you are able to do 2 things in M and N ways respectively, then you can perform both the things simultaneously in Mn ways, that is called rule of multiplication. Now by following that rule, we have to select one ball from red and one ball from blue and one ball from black. So that is we have to perform 3 tasks simultaneously. So one ball from red means 2C1 multiplied by one ball from blue means 3C1 and one ball from black means 4C1. So 2C1 into 3C1 into 4C1 is the favorable cases. So the probability of getting 3 different balls is 2C1 into 3C1 into 4C1 by 9C3. If we simplify, we will get the answer that we require. Now we go to solve the second bit. In this question, we are asked to find the probability of getting 3 balls of same color. That is all the 3 balls of blue color or all the 3 balls of red color or all the 3 balls of black color. Okay, so the question is 2 balls are of same color or 3 balls of same color. So for that the possibilities are all the 3 balls are of blue color or all the 3 balls of black color. That is the only 2 because red is only 2 balls we have. So that only 2 possibilities are getting all the 3 blue balls or all the 3 black balls. So both are mutual exclusive and hence the probability will be P of getting 3 blue balls plus probability of getting 3 black balls. So there are total 3 blue balls and hence 3C3 by 9C3, and there are 4 black balls and hence the probability will be 4C3 over 9C3. In this way we can find the probability of getting 3 balls of same color. Now we are going to solve next problem. Probability of getting 2 balls of same color and third one is different. That means the possibilities are drawing two blue balls and one the other color, that may be black or red, and or drawing 2 black balls and the third one is different, and or drawing 2 red balls and the third one is different. So there are 3 different cases. So case 1, 2 blue and 1 is different. 2 blue means 2C1, different means the sum of black and red, that is 7C1. So 2C1 into 7C. The second case is 2 black and 1 is other. There are 3 black balls, so 3C1, and the other 2 red plus black are 6, so it is 6C1. 3C1 into 6C. And the third case is 2 red and 1 is other, that is 4 red balls, 4C1 into 5 balls other, that is 5C. So in this way we can calculate the probability of getting 2 balls of same color and third one is different. So with this problem I'd like to conclude the lesson. And um, so in the first 2 lessons we have discussed what do we mean by random experiment class, and event, what is an event of a random experiment, what is the sample space of a random experiment, what do we mean by mutual exclusive events, and what do we mean by equally likely events. And then we have defined the classical definition of probability, that is P of A is number of favorable outcomes of A over number of total possible outcomes, n of A by n of S. Also we have seen the axiomatic approach, axiom of certainty, axiom of positivity, and axiom of meaning. Axiom of positivity says that probability is always positive. Axiom of certainty says that sum of all probability is always 1. And axiom of union says that if A and B are 2 mutual exclusive events, then P of A and B is equals to P of A plus P of B, provided A and B are 2 mutual exclusive events. And then we have seen that the complementary probability, that is P of A complement, is 1 minus P of A, that is failure probability is equal to 1 minus success probability. And also we have seen that P of S is 1 and P of phi will be 0. And also we have seen the formula of P of A and B as P of A plus P of B minus P of A in section A, which is called as additive law for 2 events. And also we have seen additive law for 3 events, P of A union B and C is equals to P of A plus P of B plus P of C minus P of A in section B minus P of B in section C minus P of C in section A plus P of A in section B in section C. Also we have seen some problems on deck of cards, tossing coins, rolling dice, etc., etc., and also selection of balls, different colored balls, based on additive law and classical definition problem. With this, I would like to conclude this lecture, and we'll meet with one more important topic on probability in the next lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.